Day 627 of doing a Leetcode problem every day until I get a job. All right, y'all, we're back again. Another day, another Leetcode problem where we're doing daily Leetcode problems. And today we have question number 3314. Construct the minimum bitwise array 1. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array nums consisting of n prime numbers. You need to construct an array of ands of length n such that for each index I, the bitwise OR of ands I and ands of I plus 1 is equal to nums of I, i.e. ands of I or ands of I plus 1 is equal to nums of I. Additionally, you must minimize each value of ands of I in the resulting array. If it is not possible to find such a value for ands of I that satisfies the condition, then set ands of I equal to -1. All right, y'all, so that sounds simple enough. But before we get into the solution, let's go ahead and take a look at these examples just to make sure that we're doing this problem correctly. Now, before we get into example 1, let's go over what a prime number is. It says a prime number is a natural number that is greater than 1 with only two factors, 1 in itself. So, and as you can see in example 1, our input is all prime numbers. So let's get into it. It says in example 1, our input nums equals an array of integers 2, 3, 5, and 7. The output is -1, 1, 4, and 3. So let's go ahead and take a look at this explanation so we could break down how they got this output from this solution, right? So it says for I equals 0, which is this right here, 2, it says there is no value for ands of 0 that satisfies the condition ands of 0 or ands of 0 plus 1 is equal to 2. So we return a -1 for ands of 0. That's where this -1 comes from. And I'll show you what they mean by that now as we get into ands or I equals 1, where there is a value that satisfies the condition. So you can see, right? So ands of 1, when I equals 1, that's when I equals 3 right here. We're looking at index 1, I equals 3, right? It says the smallest ands of 1 that satisfy ands of 1 or ands of 1 plus 1, excuse me, 1 is equal to 3 is 1 because 1 or 1 plus 1 is equal to 3. So let's break this down a little bit more, right? So we're looking at nums 1, which is, or I, which is 3 right here, right? So that means whichever value we put right here when we do this value or this value plus 1, and when I say or, I mean bitwise or, excuse me, y'all. So when we do this value, bitwise or this value plus 1, then we should get 3, right? So let's go ahead and see if that works, right? So this value is 1, so we do 1. It should be 1 or bitwise or 1 plus 1 because this is 1, so we're just going to add 1 to this one, right? Because it says ands of I plus 1. So boom, it will look like this. So that's going to turn into 1 or 2, right? Because 1 plus 1 is 2. So when we do 1 or 2, we got to use binary for this, or base 2. We're going to say 0, 0, 0, 1. That's for 1. That's the bitwise representation of 1. Then we need the bitwise representation of 2, which would be 0, 0, 1, 0, right? Boom. So when we compare these using the bitwise OR, which is this right here, boom, let's just clean this up. Boom, this sign right here, when we compare these doing the bitwise OR, every bit where there's a 1, if there's excuse me, if there's a 1, then that means the output is going to have a 1. So when we compare the values, if there's a 1, it's going to be a 1. So for this, when we compare these two values, those ones is just a 0, so we can put a 0. Hold on. Boom. Let me clean this up for y'all. Boom, 0, because there's no 1s. Then right here and right here, once again, no 1s, we can put a 0. Boom. Compare this and this, oh, we have a 1, so we put a 1 right here. Boom. When we compare this and this, oh, it's a 1 right here, so we put a 1 right here. Boom. I'm gonna put a space right here. Now this right here is equal to 3. Boom. Let me just clean this up. This is equal to 2. Or excuse me, this is equal to 1. This is equal to 2. Boom. But what's important is this is equal to 3, right? So this right here, or this element right here, when we follow these requirements that they give us, right, which is right here, 1, the value is 1, ands of I is 1, right? So 1 bitwise or 1 plus 1, which would be 1 bitwise or 2, that's going to give us 3, right? Boom. And that's what we want because this is 3. So this, when we bitwise or this plus 1, we're going to get 3, which is what we want. Now, say we change this, say we tried try the 2 right here, right? So we try the 2 right here. Let's come down right here so we can see what it would look like with a 2. So if it was a 2, it'd be 2. Oh, sorry, y'all. It would be 2 or open up the parentheses 2 plus 1, which would be 3. So that would turn into 2 or 3. Boom. And then so the bit binary representation, and this would be 0010. Then it would be for 3, it'd be 0011. Now, as you can see, when we do the bitwise OR, no ones here, 0. No ones here, 0. We have a 1 here, so that's a 1, and we have a 1 here, that's a 1. So that equals 3 as well. Boom. So let's do this. This would be equal to, excuse me, y'all. This would be equal to 2. This would be equal to 3. Boom. And when we compare them, we get 3 as well. So if we had a 2 right here, it would fit the requirements as well, right? However, we want to minimize each value. So since 1 gets us a 3 when we follow these operations, and 2 gets us a 3 when we follow these operations, we're going to go with the smallest one, which is 1. Boom. So that's why the 1 is right here. Now let's continue through the example. Don't worry, I'll go through them all for you guys. Boom. So now we got this -1, and for this -1, there was no possible answer for us to get for our bitwise to equal 2. So we just return -1. Boom. Then 1, or then for 3, it was possible with 1. Now for 5, right? So they're telling us, we already know it's 4. It says for I2, the smallest ands of 2 that satisfies ands of 2 or ands of 2 plus 1 equals 5 is 4, because 4 or 4 plus 1 is equal to 5. Boom. So let's go through it. Now we have 5, right? So we want to put a number right here that fits these conditions, right? This number or this number bitwise or this number plus 1 should give us 5. Boom. So we already know it's 4, but let's just make it make sense anyway. So 4, we're doing 4 bitwise 4 plus 1, because that's what we're supposed to do, right? Boom, right here. Boom. Or in this where the or come from. Boom. So what that's going to look like is 4 or bitwise or 5. Boom. So let's see what that looks like in binary representation. So 4 would be 0, 1, 0, 0. That's 4. And then 5 would be 0, 1, 0, 1. Boom. So let's compare the two. When we compare these, we can start from over here. We compare these, no ones, 0. Boom. We compare these, it's a 1. Compare this, 0, 0, no ones, 0. Come right here, it's a 1, 0. I mean, it's a 1, so we put a 1. So once again, let's see, this equals 4. This equals 5. And as you can see, when we compare it, this equals 5 as well. So that's why this 4 works, because when we do this 4 and we bitwise or this 4 by 4 plus 1, or by 5, when we do 4 bitwise or 5, that's going to give us 5. Boom. And before we get into it, just know when we do 3 bitwise or 4, because 4 is 3 plus 1, is going to give us 7. Now we're going to go through it. I'm just letting y'all know what to look out for, because I already know how it's going to work, right? Because 3 bitwise or 4, that's going to equal 7. So let's go through it though. It says for I equals 3, the smallest ands of 3 that satisfies ands of 3, or bitwise or ands of 3 plus 1 is equal to 7 is 3, because 3 or bitwise or 3 plus 1 or 3 bitwise or 4 is equal to 7. So let's go through it. So now we want to get 7, right? And they tell us the answer is 3. So we do, that would be look like 3 bitwise or 3 plus 1. Once again, so we're going to say 3 bitwise or 4. Boom. So let's look what binary representation for 3 looks like. That's going to be 0, 0, 1, 1. Set that equal to 3. Then 4 is going to be 0, 1, 0, 0. That's equal to 4. Now remember, when we compare them, it should equal 7. So let's compare them and see what we get. 0, 0, that's going to be a 0. 0, 1, that's going to be a 1. 1, 0, that's going to be a 1. 1, 0, that's going to be a 1. And this is equal to, guess what, y'all? 7. Boom. So that's why this 3 goes right here, because it satisfies this condition once again. And boom, that's how we got this output. Now, just in case that didn't make sense, y'all, let's take a look at example 2. Example 2, same principles apply. It's just little bigger numbers, but hey, we can get through it. So it says in example 2, our input nums equals an array of integers 11, 13, and 31. The output is 9, 12, and 15, right? So let's go through it. It says for I, for I equals 0, so that's 11 right here. Boom. The smallest ands of I, or ands of 0 that satisfies ands of 0 or ands of 0 is 11, because, or is equal to 11 is 9, because 9 or 9 plus 1 equals 11. So that's where this 9 comes from, excuse me. So let's see how they got that, right? So 9 in binary, let's see what 9 in binary is. Give me a minute, y'all. 9 in binary, well, let's get rid of this 2 first. Boom. So 9 in binary is going to be, well, first let's set it up like this. 9 or, let's do it right, y'all. Let's not cut any corners. So that's going to come to 9 or 10. Boom. So let's see what 9 or 10 looks like. So 9 binary is 1001, and then 10 binary is 1010. Boom. Then when we compare the two, that's going to give us a 1. That's going to give us a 0. And this is going to give us a 1. And then this is going to give us a 1 as well. That's going to be 100, or it's going to be 1011. That equals 11, which is what we want right here. Boom. So that's where this 9 comes from. Now let's go through this. For I equals 1, meaning index 1, the smallest ands of I that satisfy ands of 1 or ands of 1 plus 1 equals 13 is 12, because 12 bitwise or 12 plus 1 or 13 is equal to 13. Boom. So now looking at 13 in the input, the output is 12. So let's see how they got that, right? So we take 12, once again, bitwise or 12 plus 1. That's going to give us 12 or 13. Now, give me a minute while I find 12 and 13 in binary. One moment, y'all. When we get this, so 12 and 12 in binary is going to be 1100. 13 in binary is going to be 1101. Boom. So we come underneath this. Let's compare. We get 1. Then that's going to be a 1 as well. That's going to be a 0. And that's going to be a 1. So once again, hold on. This is equal to 12. This is equal to 13. This is equal to 13. So once again, when we compare these two numbers using bitwise OR, we get 13, which is what we want, because that's at index 1. Now, let's get into the final part of this example. We need 31, right? So give me a minute. Let me see what binary 31 is before we get started. Well, I guess I need, hold on. Let me see. I gotta get what is binary for 15 and 16 as well. So give me a minute. Well, let me see. One moment, y'all. Let's see. Boom. Okay, we got it. So this is what we're dealing with right here. Let's see. So 15, this is what we got. So 15, we want to do, let's get rid of this. We want to do 15 bitwise or open up the parentheses 15 plus 1. Boom. So that's going to be 15 bitwise or 16, right? Boom. So 15 and binary is going to be 1, 1, 1, 1. That's 4 ones. Then 16 and binary is going to be 1, 0, 0, 0, 0. Boom. Then, or I guess we could do it like this. Boom. Then, when we compare these, we should get 31. So let's see. We're gonna have to carry a 1. So it's gonna be 1. This will be 1. Oh, sorry, y'all. Let me see. This will be 1. Boom. We compare these. Compare these. This is gonna be 1 as well. Boom. Sorry, y'all. Boom. Then we're gonna this will be 1. This will be 1. Sorry, y'all. Then we would imagine a 0. It would be another 1. And then, so in total, this right here is equal to 31, right? So 31 has 5 zeros, right? That should be 5 zeros. Boom. And then this 15 and 16, 15 has 4 zeros, 16 has, or not zeros, 15 has 4 ones, 16, this is 16 right here. When we compare these, we're going to have to imagine a 0. Right, so then that's where this one comes from. And in the total, this is 31. Boom. Let me just clean this up for y'all. 16. Boom. This is 15. Boom. And that's how we got this right here. This 15 comes from this right here. This is how we got it. This is the 31. Boom. So that's how we got this output from this input, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. So let's get into it. Now, first thing we are going to do is this array will store the result for each number in nums that we're about to create. So we're going to create an array, come right here, called result, or it's going to be a variable called result, and we're going to set that equal to an array of integers, integers, and put the parentheses like that. Boom. Now we're going to iterate over each number in the input array by saying for num in nums, we're going to open up the brackets. Then we're going to use a flag to check whether a valid value of I was found. So we'll declare a variable called found, and we will set that equal to false. Boom. Then we're going to try all possible values of I from 0 up to num. So we're going to say for I in 0 num. We'll open up the brackets. And we're going to check if the bitwise OR of I and I plus 1 equals the current number num. So we'll say if I bitwise OR, open up the parentheses, I plus 1, come outside of that, equals num. It's that simple. That's how we got to check it. Boom. Then we could just say if the condition is satisfied, we just need to append I. So we can say result dot append, open up the parentheses I. Then we set the flag to true. So we'll say found equals true. Then we'll break. Boom. Now, if no valid I was found, then we need to append -1. So we come right here, still inside the for loop, and we'll say if exclamation point found, open up the brackets, we're going to say result. This means it's not found. That's what this exclamation point means. We're going to say result dot append, open up the parentheses, -1. Boom. And then we need to return the result array by coming right here, and we could just say return results, y'all. That should be all she wrote. Let's give it a run before we submit it. Make sure it runs correctly. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users, y'all. That's what I'm talking about. That's what I like to see. So, with that being said, y'all, make sure you get one more look at the code. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another Leetcode problem. See y'all then.